Alrighty guys, so I'm going to make this video to go over the study guide and provide you some answers. And this is for you to check your answers. It's not to copy down my answers and earn the bonus point credit, okay? Preface this video with this. If you are watching this to copy down my answers and get bonus point credit, that's not going to work. It's not going to fly. This video's purpose is for you to check your answers after you've completed the study guide, and if anything is incorrect, you can fix it. Okay? So as I said earlier, I do want you, if you feel like you need to complete the study guide for more help, then please do so. But if you feel like you're good to go and don't need to do the study guide, that's fine. You don't have to do it. It's up to you. But for those who choose to do it, I'm giving you answers so you can check. Okay. Number 1, are W, V, and X collinear? If so, name the line on which they lie. So we have to remember what collinear means. Collinear means that the 2 points are on the exact same line. So let's find those points. W, V, and X. Are all three on the same line? No. These are not collinear. What is the intersection of plane W, X, Y, Z and plane V, U, Y, Z? Okay. We're talking about where two planes cross. Remember we said that two planes intersect at a line. So hopefully these two interplanes intersect at a line. So let's find that. W, X, Y, Z is the bottom. So I'm kind of like shade where that's at. V, U, Y, Z. V, U, Y, Z. That's the front. Let me shade it differently. Do it this way. So WXYZ is the bottom of the plane, and VUYZ is the front. Those two are intersecting right here. So you could say the line YZ or ZY. One of those two. Remember? And remember, we have to use the lines because planes intersect at lines. So to say it's a line, you put the little bar with two arrows on the end. Okay, name the line in the plane shown in the figure. So for the line, you need to use 2 points on that line. So we could say VW, or you could do WV. Now, we did talk about an option where if you have a lowercase letter at the end of the line, like J, like that, you could use that. But we don't have that here, so we're not going to use that option. All right, now for the plane. So for plane, you actually have to write the word plane out. And then to name a plane, you have to use 3 non-collinear points. So 3 points that are not on the same line. So I could say X, Y, or sorry, not X, V, V, Y, W. Or I could use V, W, X, or you get the idea. It's just 3 points that aren't on the same line, but they're inside the plane. That's what you need. All right, number 4. Which diagram shows a plane PQR and plane QRS intersecting only at the line QR? So on this problem specifically, I just kind of read each diagram and see if it fits the description that we have. Right? PQR, that's one plane, and then QRS is the other plane. and we want it at line QR. So see how this line is right here diagonally? That is where the two planes are intersecting. And if we want the line to be named QR, then essentially points Q and R need to be on that line. And just from looking, it looks like choice A is our answer, because this one has the line QP, this is SR, and that's RP. So it's really just reading your diagram. Okay, number 5, name the ray. How do you know it's a ray? Because it has one endpoint and extends infinitely in another direction. To name the ray, remember you start with the endpoint. So our endpoint here is C, and then we travel towards D. Let me rewrite that because I don't like the way I wrote it. And then to name a ray, you put a bar and one letter. Or not one letter, sorry, I can't talk. One arrow. All right, number 6. Name a ray that is opposite ray BD. So let's find ray BD first. Ray BD says you start at B and go towards D. And if you want to be opposite, remember opposite rays, they have to share the same endpoint. So our opposite ray needs to start at B and then go in the opposite direction. Okay, so if I run the opposite direction, notice I'm going to run through A. So that's going to be my opposite ray. Start at B, go towards A, put my ray sign. There we go. Excuse me. Name 4 segments that are skewed to GC. So let's find GC first, just so I can remember what we're looking at. So right here's GC. What does skew mean? Skew means that the lines are not in the same plane, and so they're not parallel. So it's non-coplanar, non-parallel lines, essentially. So if we're looking here at GC, I would say one of them is AB. So remember, we're talking about segments. So segments is the 2 points in just the bar. Okay. So AB is one. I would think EF is another one. Can't use AE because that's parallel. Can't use BF, that's parallel. Can't use DH, that's parallel. So I would think FH is another one. There should be one more. AB, EF, FH. Sorry, y'all having to think a little bit. That check mark are the ones we can't use. AB, F, FH. Oh, BD. There it is. Sorry. See, I can get the first 3. The 4th one takes me a minute, but that should be all 4. All right, 3 labeled segments parallel to GC. So now let's go back and highlight GC. And remember, we know what parallel means. Parallel means they don't intersect. But in geometry, we have the stipulation that the lines need to be in the same plane. So in other words, they need to be on the same face of this prism thing. So GC is what we're looking at. The first one I notice is parallel would be AE. And then DH. That's the 2 most obvious. There's another one, and it's actually BF. Now remember, it's BF because we have these things called diagonal planes. where they kind of come through the figure. And so we have to also include the diagonal plane. So GC is also parallel to BF on that diagonal plane. Which plane is parallel to plane CDHG? Where is CDHG? CDHG, that's the front. And so we have to use the back one. So we would say plane A, B, F, E, or something like that. All right, moving on. Find BD. This is we're using the ruler postulate, so you could use the absolute value thing. Let me show you that, just in case somebody uses it. I don't think you'll use it, but just in case somebody decides to do it. So, absolute value. You start at B, because we're going from B to D, so B is at -4, minus, where's D at? D is at 8. We simplify that, and we end up at, whoops, you can't see that. There we go. So 12 is the answer using the actual ruler postulate, but let's be honest, how many of you are going to do that? Probably none of you. You're probably just going to count. So you just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Boom, there you go. Either way you want to do it. You want to use the absolute value thing? Cool beans. You want to count? Doesn't matter. I don't care. All right, number 11. If EF is 2x minus 11 and FG is 3x minus 10, EG is the whole thing. Find the values of X, EF, and FG. So this is where we use our segment addition postulate, which we said was essentially a piece or a portion plus the other piece or portion equals the whole thing. So I'm going to write that out. My first piece is 2x minus 11, add my other piece, 3x minus 10, equal it to the whole thing, which is 24. Combine like terms, 5x minus 21 equals 24. Add 21. 5x equals 45. If I can do math, yeah. Divide the 5, x should be 9. So that's part of the question. We had to find x. And now we need to find EF and FG. So EF, we'll plug in the 9. 2 times 9, subtract 11. That should be 7. And then FG is 3 times 9, subtract 10. That's 27, subtract 10, so 17. There we go. Which point is the midpoint of AE? So let's find AE. Notice AE is on this number line, so we need to use our ruler postulate first. How long is AE? So let's find how long that is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's 16 long. So remember, midpoint is the point that cuts it in half. So we have 16, so half would be 8. Which point is 8 away from both endpoints? And if you just do a little counting, it looks like it's D. So D's our midpoint on number 12. Number 13, if T is the midpoint of SU, find the values of X and ST. So midpoint, remember, is it's in the middle and it cuts each piece in half. So we're going to set both pieces equal to each other. Excuse me. Now we'll subtract 4x. 3x equals 33. Divide the 3 out and you get x to be 11. We want ST. Remember, ST was this one, so it's a 7x. So ST is 7 times 11, which is 77. Number 14. If the measure of angle BOC, so anytime they give me a labeling or a picture like this, either a segment or an angle, I'm going to label it. BOC is 24, and AOC is the whole thing. What is the measure of AOB? So this is a question about the angle addition postulate, which is the same idea as segment addition postulate. You're using angles instead of segments. Notice they gave me a piece and the whole. So if I were to write this out, I would say the measure of AOB plus the measure of angle BOC equals the measure of angle AOC. Plug in what we know. I'm being really technical here. Oops. Obviously, you don't have to do this if you know what to do. I'm just showing you what you would do. So this would be 50 subtract 24, which should be 26 degrees. All right. If the measure of angle DEF is 125 degrees, what are the measure of FEG and the measure of HEG? So I'm going to write those out. And honestly, guys, these are stupid easy, but what's going to trip you up is on the test, it's going to be multiple choice, and they're going to have the numbers in different spots. So you have to pay attention to the letters and the numbers, okay? So FEG, that is an adjacent angle, meaning it's next to the 125, okay? Now, it's adjacent, but there's also another relationship going on here. Whatever FEG is, it plus 125 makes 180. Well, how do I know that? Because I just drew a half circle. And if I can draw that half circle, that means those two angles are what we call supplementary, meaning they add up to 180 degrees, or they're also called a linear pair because they are next to each other and they form a line or the straight angle of 180. Okay, so sometimes supplementary and linear pair are the same thing, especially when they're next to each other like this. So how do we get FEG? We simply subtract 125 from the 108, or 180. 180 minus 125, it is 55 degrees. Okay, where's HEG? HEG, this is what we're looking for, this angle right here. HEG and the 125 are in a vertical relationship. How do I know that? Because I kind of have an X shape going on here. Remember I said that the angles that are across from each other in the X shape are congruent, meaning they're the same. So this one is also 125. Number 16, name an angle supplementary to angle COB. COB, I'm going to mark where we're at. I like to put my little arc. So that's the angle we're talking about. And if I want to make a supplementary angle, I need to basically what I do is I keep drawing this until I get my half circle. All right, so I'm going to do that. All right, there's my half circle. Now we already have this portion of it that I just marked with a tick. So the rest of this, who is it caught between? Well, it goes from EOB. So we would say angle, you could say angle EOB or angle BOE, whichever way you want to do it. All right. In the figure below, the measure of angle AED is 118 degrees. Which of the following is false? So let's read each of these carefully. Angle BEC and angle CED are adjacent. So let's look. BEC, there's one angle, and CED. They're saying that angle and that angle are adjacent. What's adjacent mean? It essentially means they're next to each other and they're kind of stuck to each other. So it looks to me like they're adjacent because angle BEC is right here, CED is right here. They're sharing that side and that vertex, so A is not an option. AED and BEC are adjacent. Is that true? AED, BEC. Well, do that one more time. AED, BEC. I see an X shape going on, and those two angles are actually across from each other. So I'm thinking they're actually vertical, so I'm going to mark that as being the incorrect option, but let's check the other two just to be sure. The measure of angle AEB is 62. AEB, is that 62 degrees? Yes, because we can make a linear pair here, and then 180 subtract 118 is 62. And then BEC, that is 118 because it's vertical. So our original choice of B being the false one is correct. Number 18, how are they related? Well, they're not touching, so it's not going to be vertical or adjacent or anything. But notice I've given you actual angle measures. Add those two up and see what you get. And if you do that, you'll see they add to 180, so they're supplementary. Remember, just because they don't touch does not mean that they can't be supplementary. That was a lot of negatives in that sentence. Let me rephrase what I was trying to say. Supplementary angles do not have to touch to be supplementary, and neither do complementary. They just add up to either 90 for complementary or 180 for supplementary. Okay? The complement of an angle is 69 degrees. What is the measure of the angle? Complement your keyword there. It sounds like complementary. So the 69 plus what we don't know is supposed to equal 90 because it's a complement. So really, we're just going to do 90 subtract 69. We should get 21 degrees as our angle. Let me double check myself. I don't trust myself. Yep, 21. All right. The two angles are complementary. So remember, complementary is they add to 90. The measure of one angle is x plus 5. The other one is x minus 7. Find the measure of each. So what do we do here? We're going to take the first angle, add it with the second angle, and equal it to the 90. Let's combine 2x, 5 minus 7 is subtract 2. Add the 2. 2x equals 92. Divide 2, x should be 46. Yep, 46. So I want the measure of each angle, so I actually have to go plug them back in. So, and I encourage you to do this on your test. Write out these letters, the measure of D, F, G. That was x plus 5. So what we get for x? 46. Add 5 to it. That's 51 degrees. The measure of angle JKL, that was x minus 7. So our x, subtract 7, that should be 33 degrees. I'm an idiot. I can't do math. That's not 33. It's 39. There we go. Now, how could you screw this up? Number one, you could have got these numbers wrong, but honestly, you shouldn't because you've got x. You just plug them in the right spot. What the test is gonna trip you up on is they're gonna switch the positions of these letters. So if you write this out like I've got here, you should not miss it. Okay, you just pay attention to each choice. DFG 51, JKL 39. The choice is A. All right. Similar question, except now we're supplementary. So remember, that is add up to 180. So the same setup, x minus 39 plus x plus 79 equal to 180. Combine. All right, now we'll subtract. 2x is 140. Divide your 2, x is 70. So again, write them out. The measure of angle 1 is x minus 39. So take our x that we just found, subtract 39 off of it. We get 31 degrees. The measure of angle 2 was x plus 79. So take our x, add 79 to it, and we get 149 degrees. So angle 1 was 31, angle 2 is 149. How do you know if you're right? Add them together. Oops, I can't type. There, you get 180. All right. I see the word bisect, so we have an angle bisector question going on here. So let's pay attention to what they give us. The measure of angle LMO, I'm going to label that 6x minus 30. And NMO, 2x plus 30. Solve for x and find LMN. Okay, this is a situation, one of the situations that we had on our assignment. There was two possibilities. You either were given both pieces, in which case you set them equal to each other, or the other option is you have one piece and the whole, in which case you double the small piece and equal it to the whole thing. We don't have that here. But remember that case, because that could come up on the test too. We have both pieces, so we're going to set our pieces equal to each other. And we'll solve. Move the smaller x is always a good option. Now we'll add 30. 4x is going to equal 60. Divide 4, you get x to be 15. So that was one choice. One thing we had to find. Now we want the measure of LMN. What I'm going to do is just plug 15 back into one of these expressions. Just one, let me rephrase that. I'm going to do that, plug it into, let me show you what I'm going to do. So, 2 times 15 plus 30 equals, 2 times 15 is 30, 30 plus 30 is 60 degrees. So I just found that this piece was 60 degrees. What I can then do, the measure of angle LMN, remember, this is a bisector, so this is half of the big angle. I just found half of it to be 60. So if I double 60, I'll get my whole answer of 120 degrees. That's how I do it. My brain just thinks to put it in one and double, because to me it seems like less work. But what you could do is plug the x back in both of these and just add your two answers together. It's really the same difference. Okay, this might be the other example of bisector. So let's see. LMN, that's the whole thing. 5x minus 25. And then LMO is x plus 31. Find NMO. So notice now we have a piece and the whole thing. And this piece is precisely half the big angle. So remember, this is where you double the half and equal it to the whole. We'll simplify. We'll solve. Whoops! Yeah, that's right. Sorry. Momentary brain fart. Now we'll add 25. My work's going all over the place. 87 equals 3x. Divide 3. X is 29. We want the measure of angle NMO. So look, NMO. That's the other half. And if we know what this half is, once we find it, it's going to be the same for that. So honestly, this is another x plus 31. So we're going to take the x we just found and plug it in and add that. 29 plus 31. Is that another 60? Yeah, 60 again. Yep. All right. Find the distance between these 2 points to the nearest tenth. So what you need to do is use your distance formula. And because it's a tenth, you will actually give me the decimal place. All right. So your distance is big square root, and this first set of parentheses, it's going to be where you subtract your x values. I generally start with the second one and then go to the first one, but you don't have to. You can start with the first and go to the second if you want to, but I don't do that. So 7 subtract 8 squared plus the second y subtract the first y squared. Now what I'm going to do is everything underneath here, I'm going to type that in. So we get 10. And then now you actually go back and type the square root of 10. We want the nearest tenth, so we go to the first decimal place, look behind, round appropriately. So it's going to be 3.2. Okay. Each unit on the map represents 5 miles. What that means is each one of these little lines is 5 miles. And we want the actual distance from oceanfront to seaside. So what we need to do is we'll actually calculate the distance using our distance formula, and then we'll multiply our answer by this kind of scale factor here, okay? Hold on just a second. Let me section off here. I want to right over in that space. So our distance formula. It might help to find where the coordinates of those two cities are at. So let's do that. Seaside is -2, 1, 2, 3, 4, up. So this is -2, 4. Oceanfront is 1, 2, 3, 1, 2, 3. To the right, and then 2 down. And we'll use those coordinates. 3, subtract -2 squared plus -2 subtract 4 squared. Oops, I went over there anyway, but that's fine. 3 subtract -2 all squared plus -2 subtract 4 all squared. So this turns out to be the square root of 61. We need the decimal of it, so let's find that. So it's about 7.8. Oops. I think for this problem, it might be better if we round to the nearest whole number. So let's round to the nearest whole. So 7.8 round up to the whole, it's about 8. And then we'll take our scale factor of 5, multiply the two, 5 times 8, so we get that it's choice B. It's about 40 miles apart. All right, find the coordinates of the midpoint. So these are our endpoints, so remember midpoint, you actually get another coordinate, so you need to write it as a coordinate. You basically add the x's up, take half of them, add the y's up, take half of it, and then just simplify it out. You could do it in your head or use alpha y equals and type it all in at once. 6, 4 plus 6 over 2, 5. However you want to do it. Okay, let's again write out where these coordinates are at. So P is at 1, 2, 3, 4, 5, 6, 7, 8. -8, comma, -2. Q is at 1, 2. 1, 2, 1, 2, 3, 4, 5, 6, 8. -8. And so we'll write our midpoint out. First x, add the second x, divide 2. the second y, add the two y's together. Negative 8 plus 2 divided, whoops. Oops, I did do 22. That's funny. Negative 3, negative 2, plus negative 8. You could go ahead and make that minus 8 if you wanted to. Negative 5. All right. M is the midpoint. So we actually have the midpoint. We have one endpoint, we want the other one. So remember, we're actually using our formula here. So it's like we've done this work already and we've gotten this coordinate. So what I'm going to do is the x of the actual midpoint, I'm going to set equal to this and plug in one of the x's. So 1x was 7, so 7 plus x2 divide 2. And then we'll do the same thing for the y. 6 plus y2 divide 2. Remember, whatever this is, we multiply across over there. So 8 equals 7 plus x2. Subtract 7. 1 is x2. Same thing, multiply. 8 equals 6 plus y2. Subtract 6. 2 is y2, so the other endpoint was 1, 2. All right, there you go. That's your study guide. So make sure that you try, if you're going to do the study guide for bonus points, make sure you try every problem, show all your work, and then you can watch this video to get your answers and make sure you did everything correctly. As always, if you need help, let me know.